Okay, good morning and welcome back to the next session on basics of software, that is part 2. So, yesterday we have seen some details about solid modeling, but we have not gone through details because we don't have any software. So, currently we have to go for theory contents which are related to our subject, but which are related to subject but not in actual syllabus. Okay, so we are going to start today, that is two-dimensional drawing. Three-dimensional objects have traditionally been drawn using two dimensions. Just I have explained in the last lecture, that is there are three dimensions. Every object in the universe is having three dimensions, but we have drawn only two dimensions on the sheets. Means in first year you have learned about engineering graphics 1 and 2. In that you have drawn only sheets. So three-dimensional objects you have drawn by traditional way by using two dimensions only. In that you can observe here, department is written, drawing name is written, your name, scale, then your first angle or third angle projection, whatever maybe details are there, you have inserted on the sheet which you wanted to. Then the next thing, that is two-dimensional drawing. That is 2D is not ideal for representing 3D objects. 2D has no z-axis, as I have told in last PPT, that is last presentation, that is two-dimensional thing has no z-axis. 2D is very flat. Now let me tell you some basic details related to it. With the help of text typing, I will go for it. So first of all, we'll go for what is 1D, what is 2D, and what is 3D. So in 1D, there is, if we are considering x, y, and z direction, that is, I will tell here. So I will draw here text for 1D. So if you want to draw 1D object, in that case, the x distance, x axis distance, direction, length of an object is very greater than other two, that is y direction and z direction. Means what? I will draw here text again. Suppose this is x axis, this is y axis, and this is z axis. So x, y, and z axis are there, but if one beam is there only, suppose I will say one beam is there which is having the length of, suppose I will say 500 mm. Okay, then it is having cross sectional area that is 10 by 10 mm. So here I will put here L. Okay, this is length. So this is length of 500 mm and area is 10 by 10 mm. So here length is x direction. If you have considered here, length is x direction and the y and z directions are nothing but the area. So the 500 is greater than other two which we can consider. Okay, so that is case of 1D element. Okay, now next one we'll go for another thing, that is 2D. In that x and y are comparable to each other and they are greater than third direction. So that is called as 2D. So no need to draw the extra drawing for this. See, this is the whole sheet. This is the sheet. Actually, it is a flat sheet having x and y directions which are comparable to each other, but it is not having z direction. That is third direction. It is having very negligible value as compared to x and y. So it has no z axis. Means it is very negligible. But when the question comes to 3D, then the object will be defined like, as I have explained in previous lecture, that is this one is there, this one is there, this one is there, and this one is there. The cubical object which I have drawn in last lecture. So this is called as 3D. So I will define 3D, that is 3D x equal to near about, it's not equal to, near about equal to y, near about equal to z dimension. So this is the case which we are going to study in this subject. I will clear all this. Now we are moving towards our next slide, that is three-dimensional modeling. 3D model include x, y, and z dimensions, as I have told before. Allows better definition of three-dimensional objects, but there are three general types of 3D models. So I have explained in 1D, then 2D, and then we have came to 3D. So in that, 3D is divided into again three types, that is wireframe models, surface models, and solid models. Next one, in that wireframe models means what? Wireframe means it's a wireframe of the structure. Suppose any mobile is there, you are handling, I hope you are handling mobile. Then in mobile, the wireframe structure of mobile roughly I can sketch like this. Suppose there might be one camera here. There, there may be any, there might be any selfie camera is there. This is kind of rough wireframe model. In that only outside edges are considered. So this is the oldest form of 3D modeling. Okay, so this is oldest form of 3D modeling. Old technology not used today, because this was used at the time of AutoCAD. We are not using, but the point is to tell you that because this is the basic and you should know. So for that purpose I am telling. Then model contains edges and vertices, cannot represent complex surface. Okay, so I will come to this point. Model contains edges and vertices. See this. This model contains some vertices. Here you can see vertices. You can see such a type of edges. Okay, so model contains vertices and edges, but cannot represent complex surfaces. Yes, it can't reflect any kind of complex surfaces, such as if we want to go for any kind of bike, then bike is having some structures which can't be shown in wireframe model. Just I would like to show you. Suppose I would like to show bike handle. Suppose this is a bike handle, and there is another side, and I have to draw here all the way the curve. I'm drawing it roughly because there is only annotation tool. See, which is very difficult to go for modeling also. So with the wireframe idea, we can't show every model. So for that purpose, we need to go for another techniques. Then no details regarding interior of the part. Yes, if we are sitting in the car, suppose the car model is here. I will draw the car. I can draw a car model here. Suppose this is the car. Wireframe of a car I will draw here. And drawing it roughly due to lack of dimensions. I hope these are the windows. These are another that side two windows. This might be of the neck. There might be a structure like this, structure like this. There is four, and maybe two here. So, and in that between, I can insert the insert the part. These are back side. So this is a rough sketch of car. In that, where is interior? Where the person is sitting? Are you getting it? The person, where should the person sit? That idea is not clear in this part. If I'm drawing in only external views of these wireframe views, I might have gone too deep of external views, then this model might have become very, very, very complex. So there is no detail regarding interior of the car. So interior means car seats or anything related to interior of the car, we can't draw through wireframe modeling. So this is ambiguous also. Sorry, clear these things. So this is the sample model which is shown here. You can refer this model, but this model is too much complex to understand. We can't understand by simple way. If that might have gone for surfacing or solid modeling, then you might have understood easily. So I will go for next slide. Wireframe models are ambiguous. What does this object really look like? This object is looking like this object is looking like this object. But from this object, this previous object, this object, we can't go for clear idea how this model looks. So this one will be false. This one will be two objects. Here, this one will be false and this one will be two objects. So we should prefer solid model instead of that wireframe model. So coming back to our regular point, that is object. This one is more correct and this one is more correct. So according to me, this is not correct, but according to me, these three are correct. So it is not clear from this picture that how the model will look like. Actually, according to this wireframe model, these all views are correct, but we can't imagine from wireframe modeling that how the actual model will look. So for that purpose, we need to go for 3D modeling and detailed drawing of every component in the drawing and with the dimensions. Okay, I will clear our drawings and I will move to the next slide. So wireframe ambiguity. Which face is front and which face is back? See, so if we are looking for this, then you may say that, so there is another figure. So you can say that the model front face is this one way. Okay, you can look by this way. But another way I can say the model has no front face. Model has only this side, and this side. The other three surfaces are not there. You can say like this also. Then this one is also this. We can say in first way, that is this is the front view, and this is all the model. But in other way, if you are going to see, then this is one surface, this is one surface, and this is one surface. Other three surfaces are not there. You can imagine by looking. This is actually illusion, so you can see that. You can imagine that what actually a wireframe view does. So it creates a lot of confusion. So to avoid that, we should go for clear kind of drawing. Next one, surface model came after wireframe model. Okay, so still used today. They are surfacing is still used today because the sheet metal surfacing is there. Now I will take some practical examples. If 1D is there, we can go for beam analysis. Okay, I will let you know later because it will create a lot of confusion because it is a part of final year study and you need to know at least software before that. So I will tell you later. So came after wireframe model. It has came after wireframe model. It is still used today. Yes, it is still used. I have also used. Model contains edges, vertices, and exterior surfaces only. See here, not interior return. Can represent complex exterior surfaces. No details regarding interior of parts. See, it is not any kind of interior particle and too ambiguous for interior. Here, if I want to represent a model, then I can represent it. So I will say here, this is the wireframe model. But I can't say this as a surface model because it can't represent any kind of surface. For that purpose, I need to divide the surface model. That is, I have to show, indicate this surface, this surface, this surface, and this surface. Again, backside surface, upward surface. So these six surfaces I have to indicate. Then next one, I can indicate with the help of some these stuff that I can do. So right now I can't show you in this software because it's a clearly annotation. So it is not modeling, but I can't show. I will show you the help of only two surfaces. The surfaces which I can show, you can see in this figure. Okay. Now I can draw these kind of surfaces, but okay, one more surface is there. I will this one. So these are the surfaces which are indicated only exterior, not interior. But see, if this figure you will see this figure. So this is the different surface. This is different surface. Here there is a different surface. Again there is a messy part. You can't get clear idea about final model. So for that purpose, we need to go for solid body. So I am telling the need of this subject. We have not started any of the syllabus content. Okay, right now. So next one. Now current state of the art. This is the clear idea which I wanted to tell you about our solid model. So before that, I will revise the concept that is wireframe modeling only exterior part, but surfaces are not shown. Likewise, we can say the human skeleton is kind of wireframe, in that we can't go for any kind of muscles, any kind of fats in the body, but it's only wireframe of the model. But in the second thing, the surfacing is there. Means human skeleton is there, but some skin is only attached to the human skeleton. Okay. And if the skin is attached, but there is no blood vessels, there is no blood or anything, fats, any muscles or no, nothing in the body, there are no eyes also, only skin is attached. Then how the body will look? It will look very bad. So accordingly, the solid model should be made. The current state of art, this is the current state of art. So model contains edges, vertices, exterior and interior surfaces, and interior details. Part is unambiguously defined, which is very important thing, and may be used for engineering analysis. Okay, we can directly go for analysis, which is not your part now, which is you will learn in your final year probably. Okay, so this is the 3D model which I wanted to show you. So I hope you have got this because I have revised the things while talking with you. Next one, applications and uses of solid representations. That is CAD/CAM. What is CAD? What is CAM? That I will tell detail someday in the next lectures because we have very restricted time. So CAD, CAM. The next one, finite element analysis. That is also final year part, which you will learn. Stereolithography. So this is the technique of 3D printing. So in that we can go for 3D printing technique, but with the help of 3D printing, not 3D printing actually, it's a rapid prototyping technique in which we can make the make the object, we can manufacture the object by giving input of 3D models only. Then component layout, interference fit, animation and interaction, engineering, medical imaging, science visualization. In medical fields also, there are a lot of uses. If you want, you can see my video in YouTube channel of Digital TV. In that, I have given a name as FEA real life approaches. In that, many kind of real life approaches I have given. You can refer that also, but it is not for your level. When you will go in final year, I will tell to you. But in that, I have given the example of Thanos, that is Avengers famous villain. So in that Thanos, actually Thanos face is not available in the whole world, but the person who was doing the role of Thanos, that person was having some structure attached to it, and that structure they are sensing, and we are using some VFX effects. But that VFX effects are not possible without this kind of machine and analysis. That is a part of final year. That is not your part, but we can go for this thing. Then we can analyze the human bone also. We can analyze anything, human teeth also, anything related to human being also. Medical applications, engineering applications. We have already some applications seen. That is every car, every chair. If you are sitting on the chair, we can go for modeling of it. We can go for analyzing it. Then interference fit. That is the concept. Again, concept in deep. You are going to learn in your third year. Then animation and interaction. That is also one of the interesting fields from childhood. You might be looking, you might be watching the animated films or some videos. Component layout, that is also there. So we can go for any kind of applications which are for your study, but we will go stepwise instead of going for once at a time. Okay, thank you. For any queries, you can contact me anytime. So I'm available.